So length of an interval, we need to know what the derivative of y is with respect to x. So this is 1/2 x minus 1 over 2x, because the derivative of natural log of x is 1 over x. And then we evaluate from 1 to 3e. So if we substitute that into the formula, we get kind of a yucky expression at first, but we can clean it up. So first thing I'm thinking is common denominators. Like this x is on the outside, this x is in the denominator, right? So here, instead of having to copy that down every time, I'm going to get common denominators. This one has a 2, this one does. This one doesn't have an x, so we'll multiply the top and the bottom by x of the first fraction, I should say. And so now that I've got common denominators, this is x squared minus 1 over 2x. So we are going to square that. So when we square that, we've got x squared minus 1 over x squared minus 1, multiplying it to itself, all over 2x squared. That's going to be 4x squared. And so when we add the 1 to it, so we have this is this right now. And if we add 1 to it, like it says inside the expression, then I can turn this into having common denominators. It's 4x squared over 4x squared plus, and then if I expand that top, it's going to be x to the 4th minus x squared minus, so it's minus 2x squared plus 1 over 4x squared. And I got common denominators, so we can add them. So 4x squared minus 2x squared, that's going to be x to the 4th plus 2x squared plus 1 over 4x squared. And I think, can we factor? Yeah, we can factor that. The numerator is going to be x to the x squared plus 1 times x squared plus 1, because I found two numbers that multiply to be 1 but add up to be 2. So in other words, it's the same parentheses times itself. So the numerator can be rewritten like this. Now that I'm here, does that help us? I just took this, oh yeah, because now we can apply the square root, right? I just took this entire inside and rewrote it as this, as x squared plus 1 squared over 4x squared. So now we can square root the top and the bottom separately. So the square root of the top is just going to be x squared plus 1. That's guaranteed to be positive. And the square root of the bottom is going to be 2. And then we technically should have absolute value of x here. That's going to be hard to integrate. We'll just we're only using positive values, so we're all set there. X has to be positive because the square root of a squared value is always positive, right? Now we can integrate. Now u is just going to be x squared plus 1, and then du is going to be 2x. Oh, wait a second. Du would be on the bottom, though. Okay, I got to think for a second. Okay, so if we rewrite, here I'll factor out that 1/2. Let's break it up, because this is all being, I factor out the 2, that's a 1/2 on the outside. And so we can break it up like this. And now we can just use the linearity property of the integral operator. So this is x squared over x makes x, and then still multiplying by 1/2, the integral from 1 to 3e of 1 over x dx. And the rest of that's just plugging things in and then using the antiderivatives that we know of, right? This is x squared over 2. We evaluate that from 1 to 3e. And then this is natural log x. This is from 1 to 3e. So you just plug everything in. So that's going to be 9e squared over 4 minus, that's 1. That's 1/4, I think. Yeah. Then over here, this is, oh, I got it, yeah, multiply 1/2 to everything. So plugging in 3e. So natural log of 3e, we can rewrite that. We need to subtract that by 1/2 times the natural log of 1. So this is 0. That's nice. So this is what I've got for an answer. You could expand this to be natural log 3 plus 1. I'm sure the software is okay with the answer we have up here. It's just a bunch of complicated simplification. So those have common denominators. Over here, this is using the properties of logarithms, is natural log 3 plus 1/2 times natural log e. So this is 1. So you can just scratch that out. And so this is probably as clean as I can make it. I guess I could get common denominators here. Yeah, that would make it a little simpler. This is 2/4. So we can add 2/4 to this. That'd be 9e squared plus 1 over 4 plus, and then a natural 1/2 natural. The 1/2 power can come inside using our properties of logarithms. So I think that's as simple as I can make it.